Welcome, dear students. Here are some photos that you used to ask me about whenever I got tagged by them on Facebook, and I used to tell you that you're going to know the meaning of these photos later. So, what are these photos about? Here comes our new chapter, titled by Antiderivatives, or what we call primitives. And as you notice, the word is antiderivatives. So there is a relation to derivatives. And because of that, let's recall about derivatives. Here is the function f of x that's equal to 3x. Then the derivative of this function is 3. So as you know, you take the number, the constant that's multiplied by x, and the derivative is 3. Also, if the function is 3x plus 4, then the derivative is also 3, because the derivative of the constant, as you know, is 0. So note that these two functions have the same derivative, and keep that in mind. Okay, here is a second degree one. It is x squared minus 3x plus 4. Then the derivative, as you know, I put the power, I multiply it by the number here, which is 1, so we will get 2, and I decrease the power by 1, so I will get 2x minus, we take the constant multiplied by x minus 3, and the derivative of 4 is 0 because it's a constant. So the answer is 2x minus 3. And finally, here is a third degree one. And as I told you, you put the power, you decrease this power by 1, so you will get 3x squared. Then you multiply the power by the constant here, you will get 6x and x power 1. Okay? Because I decreased the power by 1 and I take the constant multiplied by 3. And thus I'll get 3x squared plus 6x minus 3. What's the relation between derivatives and antiderivatives? If a function, a small function f, here, is defined on any interval I in R, then the antiderivative of this small f is usually represented by capital F. So, the derivative will be represented from now on by small f, and the antiderivative, which is the function before being derived, is represented by capital F. What's this antiderivative? It is any differentiable function that has a derivative here. That means it has a derivative over this interval I such that f prime of x is equal to f of x. So capital F prime of x is equal to small f of x. That means whenever I have a small f of x that is a derivative of a capital F of x, then I say that this capital F is the antiderivative of this small f. Back to the examples. If you remember this example, capital F of x was equal to 3x plus 4, then its derivative is 3. Now, this derivative, f prime of x, will be called small f of x. So again, the derivative will be represented by small f of x, and the antiderivative, which is the function before making the derivative, will be represented by capital F of x. Okay, let's continue. Let's go back to these photos, and as I promised, I'm going to explain. This is the symbol of the antiderivative. Here is a peeled orange. Sorry, here is the orange before being peeled, and here is the peeled orange. So the primitive of the peeled orange is the orange before being peeled. Okay, so this is like an approach to represent the derivative and the antiderivative. Here is a more clear example. Here d by dx represents the derivative, and you'll later see them. So the derivative of the meat here is the barbecue. Then I say that the barbecue is the derivative of the meat, and the meat is the antiderivative of the barbecue. Similarly here, the derivative of the cow, okay, it's just an approach. The derivative of the cow is the meat, and the antiderivative of the meat is the cow. Okay? And here are mathematical examples. Let's go back to math. First example, consider f of x equals to x minus 5. This is small f of x, and this is capital F of x, is equal to x squared minus 5x plus 1. Now, I have to show that this capital F of x is an antiderivative of this small f of x. What should I do? Let's think. So I have to show that the capital F of x is an antiderivative of this small f of x. So all what I have to do is to show that this small f of x is the derivative of capital F of x. So let's prove that the derivative of capital F of x is this small f of x. So I have to derive this capital F of x. Now, as you know, I put the power and it will be 2x, decreasing this by 1. So I will get 2x minus 5. And this is exactly equal to small f of x. And thus, I proved that small f of x is the derivative, of capital F of x, and thus I say that capital F of x is an antiderivative of f of x, which is small. Another example. Consider f of x equals 3x squared plus 6x minus 3, and capital F of x is this. I have again to show that capital F of x is an antiderivative of small f of x. Again and again, I have to show that small f of x is the derivative of capital F of x. Now, let's make some calculations. Okay, you put the power here, 3. Now, decrease this power by 1, you will get squared, x squared. Again, I multiply the power by the constant here, so I will get 3 times 2 into x by decreasing this by 1. And taking this constant, I will get 3x squared plus 6x minus 3, which is exactly equal to small f of x. And thus, I can say that this capital F of x is an antiderivative of this small f of x again and again, because this small f of x is the derivative of this capital F of x. So the small is the derivative, the capital is antiderivative. And here is the last example about this idea. Again, I have this small f of x and this capital F of x. Again and again, I have to show that f of x is an antiderivative, and to show that small f of x is the derivative. So I make the calculations. I keep 2 over 3. I multiply the power, decreasing by 1. So I will get 2 over 3 into 3x squared minus 5 over 2 into 2x minus 2. Now, I cancel 3 by 3 and 2 by 2. So I will get 2x squared minus 5x minus 2, which is exactly f of x. And thus, I say that capital F of x is an antiderivative of small f of x. Now, let's consider this remark. It's an important remark. Take this function. This capital F of x resembles this capital F of x, but the difference is in the constant. Look, here the constant is plus 1, and here the constant is plus 10, while the other terms are exactly the same. Here is another capital F of x. It is without a constant. The terms are the same as this one and this one, but here the constant is 0, for example. Here is another one. Also, the difference is by the constant. Now, if you make a look, you can notice that this and this and this and this have the same derivative, which is this. And by this, I can say that all of these may be antiderivatives of f of x, and I have so many antiderivatives for this f of x. Every time I change the constant, I will get a new antiderivative. And that's why every time I'm asking you to show that capital F of x is an antiderivative, and I'm not saying is the antiderivative, because there are so many antiderivatives depending on the constant. And we'll talk about this issue in the other video, in the coming video, inshallah.